Hello, this is Math 25, Section 1.3, Quadratic Functions and Applications. So objectives for this section is graphs of the quadratic function, which is, this is what we call the vertex form, and then f of x equal to ax squared plus bx plus c is what we call the standard form. And we're also going to talk about some applications. Graphing quadratic functions. The definition of the quadratic function is derived from the Latin word quadratum for square. So which is because we have a square here. So it's a function that is written in the form of f of x equals ax squared plus bx plus c, where the a shouldn't be a 0 because a becomes a 0 and then you are losing the ax squared, so it comes as a bx plus c, which becomes a linear function. So in try to keep the quadratic function, you must see the x squared in the expression as a highest degree. Therefore, the true essence of the quadratic function is that the must has a variable with the exponent. It's gonna be the 2, so that 2, okay? So especially when you see the exponent as a degree of 2, we call the expression quadratic equation, a quadratic expression. Let's start with what is the simplest quadratic function in that it has a square variable and nothing else. So the graph of f of x equal to x squared, which is this is we call the basic functions, which could give us a parabola graph always. As a vertex of the 0, 0, and the axis metric is a y-axis because the graph open upward, and we see that the vertex is the lowest point of on the graph, which is then referred to the given minimum of the function. So in the quadratic function, you might see the minimum place or maximum values. The domain set of the all value input or x value of the functions are all real number always. And the range is always you see the graph from the vertex or above or vertex or below. So we have to say that this time is a 0 to infinity. So always positive and then 0. The first type of quadratic graph to be discussed are the transformations. So when you have a basic function, or you can call this a parent function, we could use multiple tables of the order pairs to discover the transformation relationship. However, we will take the much more intuitive approach here. Recall from the arithmetic that any number raised to an even power will never be negative. So therefore, the lowest value anything squared can be achieved is a 0. Because the square makes always positive, right? Or instead of the 0 squares only makes a 0, but other than -1 square is positive 1, -2 square also positive 4. So everything goes positive except the 0 square equal to 0, right? So you're never going to see any negative. So if we consider the expression x squared, the lowest can be is a 0, and that happens when the x equal to 0. The result that the lowest point or vertex is going to be 0, 0. So that's a minimum place. Okay, so using this idea, we will discuss the following the transformation and investigate their effects on the vertex. So our first transformation will be result and adding and subtracting number outside of the square expression. So which means we keep the x squared, but we are adding some number next to the x squared, which is one of the examples is x squared plus 2. So we are adding 2 from the f of x was equal to x squared. Okay, so let's see what happened here. So as discussed above, the lowest function or y value which is by x squared equal to 0, but it takes the place when x equal to 0. But since we consider the adding 2, so the function that simply added 2 to every output as compared to the x squared, the lowest function value reached by g of x squared plus 2 is going to be when x equal to 0, then they're adding 2. Oh, sorry, this must be a 2. So this is not true. So this must be 2. So that will be the minimum place you can see. So in other words, the function g of x equal to x squared plus 2 will have a vertex from the 0 and 2, and then all the y value going to be above the 2. And essentially shifting every graph of 2 units from the graph from the f of x equal to x squared and changing the y coordinates of the vertex from the 0 to 2. Now we consider the negative one this time, okay? So you have, there was a plus one. Now we are subtracting one. So with the same discussion as below, the lowest function or the y value reached by the p of x equal to x squared minus 1 will continue to take the place when x equal to 0. But the value reached for this function will be 0 squared minus 1, which is you get the negative 1 this time. In other words, the function will have a vertex as a 0, negative 1, and then shifting graph down 1 unit, 1 space from the graph of the f of x squared, which is a vertex going to move from the 0 to negative 1. So in summary, adding or subtracting a number outside the square expressions will shift a graphing up or down. If it's a k is a positive, going up, k is a negative, is going down, therefore the changing y-coordinates of the vertex. We will now consider what happened when a number is added, subtracted inside of the square expression. So let's see what it is. So this transformation one, we call the vertical shifting, which means it goes up and down, okay? All right, now we have a transformation 2 as it happens inside. So which means I'm adding a 2, which is 2 right here, plus 2 inside of the square. So we again use the idea that the lowest value anything square can ever achieve is a 0. Since the entire x plus 2 being square, the lowest value can be achieved is a 0. We simply need to find the x value where it occurs. So if you see that the equal to 0, so we have to looking for this value, which is set equal to 0, you'll see x must be negative 2 becomes a 0. The result that the g of x plus 2 squared will have the vertex of the this time is an x now becomes negative 2. A shifting of graph of the f of x equal to x squared to the left 2 units this time. Even though it's a plus 2, but it goes to the left. So adding the 2 inside of the square expression shifts a graph left 2 units to change the x coordinates the vertex from the 0 to negative 2. So vertex becomes a 0 to negative 2 here. Now we consider the minus 1 inside of the square. With the same discussion as before, the lowest function value x minus 1 squared can achieve to 0, and we simplify it to find the x value where this occurs. So same thing, so x minus 1 equal to 0, which is when x equal to 1, it becomes a 0. So the result in our vertex will be the 1 and 0, which means it's shifting to the right 1 units as compared to f of x equal to x squared. So subtracting 1 inside of the square expression, shift the graph right on 1 left and change the x coordinates to the vertex from the 0 to 1. In summary, adding the subtracting a number inside of the square expression will shift the graph the left or right, and especially the resulting to change the x coordinates of the vertex. So transformation 2 means we call the horizontal shifting. But one thing that we need to be careful with the horizontal shifting, when the see this is k that we need to watch out, this k, okay? So I don't it's not about the sign of the h, okay? So if this number, right, which is you can write this one as x minus of negative 2 squared. So since it's a negative 2 is h, that's why you shift into the left. But this one is already the x minus 1, so this is h right now. That's why you shift into the right 1 units, okay? So we now move on to the third transformation of f of x equal to x squared. So third transformation, now we multiply the number a in front of the x squared, okay? So this one is the difference. It's not going to be called a shifting, but consider g of x at 3x squared. So again, the lowest function value reached by the x squared is 0, and this takes the place when x equal to 0. Therefore, the function g of x 3x squared, which is simplified triple, every function value as compared to the f of x equal to x squared will continue to have x equal to 0, giving 0 as the lowest function value reached. In other words, multiplying by a constant will not change the vertex from the 0, 0, because 0 times 0 is 0 times whatever 0 is a 0. The 3 times 0 is a 0, right? So what does 3 do? As stated, the function g of x 3x squared, which simplified triple the every function value as a y. So, but vertex is y is a 0, so that's why it stays a 0. But anything, the y value, if the y value is 1 becomes 3, y value is 2 becomes a 6, everything just going to be multiplied by 3. That makes the narrow the parabola, okay? So parabola was the U shape is a parabola, okay? Which means it's going to be narrower, okay? And then consider the half this time. So a is a half of x squared. So which means it's going to be the y value will be smaller than the f of x functions. Since the function simply takes a half of the every function value compared to the f of x equal to x squared, x equals 0 will be continued to 0, the lowest function value reached, resulting in the vertex remaining as a 0, 0. So whatever, if you're going to multiply by half to the 0, stays a 0. But just like a 3x, g of x is 3x squared, but the half in the p of x will change the rate at which function rise. But since we're comparing the every function to f of x equal to x squared, which has understand the coefficient of 1 on the x squared, multiplying x squared by the positive number less than 1, we are doing that as p of x is a half of x squared, resulting in the graph of the takes up the more slowly from the vertex, giving the wider parabola. So it becomes kind of this kind of wider parabola. The last transformation, so this is a we call the stretching, which is a vertical stretching or shrinking, which is a is a greater than 1 is a stretching, a is a between the 0 to 1 is a shrinking. And the last transformation f of x equal to x squared to discuss extension of the transformation 3, in that we will determine what happened when the coefficient of x squared is a negative number. So here, now the a is negative 3 and negative 1/2. So now, since the arithmetic guarantee that the x squared never be negative, but you multiply by x squared by negative, which is you got negative 3 or negative 1/2, resulting that every function value will becomes a negative or 0, because 0 times whatever negative is 0 still. Therefore, the input of x equal to 0 into the g of x and p of x will result in the function value of the 0, giving the vertex still 0, 0, no longer is the lowest points of the parabola this time, because it's going to be the flipping the graph, okay? So you got this type of the graph, and then now this become this, okay? So as a vertex over here was a minimum, but vertex over here becomes the maximum. So it'll change the values. The negative 3 or negative half is a coefficient of x squared will result in the parabola that open downward, which is we call this is downward, and with a parabola that more narrower than the f of x squared for the g of x and wider than the f of x equal to x squared for p of x. Same thing, the narrower, wider is the same number, but because of negative, it becomes a flipping. In summary, every transformation, this can be considered with the quadratic function of the form. So f of x equal to a times x minus h squared plus k. So with that, the form, the vertex is always h and k. And then a is a positive means upward. And the a is a negative means downward. Absolute value of the a greater than 1. And that means make a more narrower. And then the absolute value is a is a less than 1, which means negative 1 and 1 between, right? Less than 1, so yeah, from the 0, right? And then more wider. And then the axis of symmetry will be the vertical, which is x equal to 0. So axis of symmetry means that the line going through this. So always x equal to h, okay? All right, so this is a because a is a negative this time, right? So we call the reflection of the reflection of vertical reflection. That'd be better. Vertical. So what happened? Vertical. Oh. Okay, hold on. So I call the vertical reflection. Alright, let's go to the next page. Let's do the example. So what if the quadratic function is not in the forms of f of x equal to a times x minus a squared plus k? Most of the definitions state that the quadratic function can be written in the forms of ax squared plus bx plus c. So there are two ways we can convert to the standard form to the vertex form. Okay, we can change that. But the good thing is this A and this A stays the same, okay? And then we just need to find the H and K from the A, B, C, okay? Now, first thing is we do the complete the square. So once you complete the square, and then we'll see the graph, okay? All right, so first of all, our function is x squared minus 6x plus 8. Okay, and then in order to complete the square, we only use the first two terms, which means these two terms. We only use this one. Okay, so what I do is b is a negative 6 as this one. Okay, so what I do is I'm going to x squared minus 6x and then take the b out and then divide by 2, which is you got the negative 6 out and then divide by 2 and then square it. But this is extra, right? This is extra. And then so what I do is if you do the immediately subtracting this, and then actually the second expression same as the first expression, okay? Because this actually these two are the cancel each other, okay? Now I'm gonna simplify. So x squared minus 6x, and then negative 6 over 2 is a negative 3. It's gonna be 9, and then this becomes negative 9 plus 8. Now you can put this 3 as a perfect square, which is this becomes a x plus b over 2 squared. Okay, so you got x plus 3 squared, which is minus 1. So now we have a vertex form, right? So a is a 1 because this is a 1. And then the vertex, which is h and k, which is a negative 3 and negative 1, okay? You always switch the sign for the h though. So if you put the negative 3 and negative 1, it should be right here. And then now you can just plug it in if you want, okay? So if you plug it in as a table, if you plug it in negative 2, okay, negative 2. So negative 2 plus 3 is 1 squared, is 0. And this is another 0 here, too. It's always a symmetry. If you plug it in negative 1, negative 1 plus 3 is a 2 squares of 4 minus 1 is 3. So negative 1 is 3 right here. 3 here. It's always symmetry because this is axis of symmetry. Okay. And then you are going to the 8. So 1, 2, 3, 4, 5, 6, 7. About here. Okay. So this is a problem. Okay. All right, let's try the second example, okay? So now example vertex, okay? So we need to use a complete the square. But this time, f of x, okay? So 3x squared plus 12x plus 13. But we are only using these two terms, okay? I'm not using 13. So what I do is, from here, I'm going to take out the 3 because x squared must be the 1x squared. So x squared, but this becomes a 4x. That's a good thing. And then inside the parentheses, I'm going to make the perfect square. So now inside is a b is a 4. So what I do is 4 divided by 2 and square. And at the same time, you subtract 4 over 2 square. And then plus 13. Now simplify, you get x squared plus 4x. And then 4 over 2 is a 2. 2 squares of 4. So add 4 minus 4 plus 13. But I only need to keep these three terms to be a perfect square, completing the square, which is a perfect square trinomial, which is a square binomial. And then I get 3 of, and then this becomes x plus b over 2 squared, which is 2 squared. But you need to take the negative 4 out from the parentheses, multiply by 3, and then you got negative 12 plus 13. And then you get 3 of x plus 2 squared plus 1. So now a is a 3, which is a positive, which is going up. And then vertex is h and k, which is a negative 2 and 1. So when you have a negative 2 and 1, it's right here. And then if you plug it in the negative 1, which is 1 square. 1 times 2, 3 plus 1 is 4. So 1, 1, 1, 2, 3, 4. And the 1 just right here. And then you get this parabola. Very narrow because of 3. Alrighty, now vertex formula. That one's kind of easier to find the graph because the vertex from, use the formula here. So in order to get an h, you put the negative b over 2a, so negative b over 2a, and then you plug it in the h into the function to get the k values, okay, which is a vertex of k. Alright, so this time, so I'm, using the same, isn't it same? Yeah. I'm using the same to get the same vertex here. So yeah, first of all, a is a 1, right, which is a positive, is we're getting a going up parabola. H is going to be negative b over 2a, but a is a 1, negative 6 is a b, and the 8 is a c, okay? So negative b, negative 6, negative of negative 6 over 2 times 1, which is 3. And then k is, plug it in, f of 3. So 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8 equal to negative 1. So your graph, your vertex is 3 and negative 1. Hold on a second. Did I mess up something here? Oh, what did I change to positive here? Yeah, I made a mistake, sorry. I made a mistake here. The region to be positive here, right? Okay. Yeah, so this becomes negative. Sorry, what am I doing? It's going to be positive 3. So your graph should be, there's no reason to be negative. Negative becomes positive, okay? So sorry about that. And then I'm going to move this graph to the on the right here. Yeah, good thing that I did it again. So 1, 2, 3, and negative 1. And then you got 1 right there. And then you get, so this time, instead of the positive, you put the positive too. So, and then you got, you can get 3, 1, 2, 3, 4, 5. And then if you put the 5, 2 square. So 2 square 4 is a 3, right? So this is going to be 1, 2, 3, right? 1, 2, 3. And then goes 8 here. Yeah, sorry about that. So your graph is in the different quadrant this time. Okay, sorry about that. Okay, yeah, so this is the right one. So you got 1, 2, 3, and negative 1. Same thing, 0, 0. For the 5 is a 3, 3, and then 13. And the a should be the minus, okay? All right. Same thing here too. So a is a 3 this time, which is a positive, which is going up parabola. Vertex h is negative b over 2a. So a is a 3, p is a 12, c is a 13, okay? So negative 12 over 2 times 3, which is negative 2. And k, plug it in h into the function, so 3 times negative 2 squared plus 12 times negative 2 plus 13. So negative 2 squared is a 4 times 12. 30 is 12 minus 24 plus 13, which is negative 12 plus 13, which is a 1. So vertex is negative 2 and 1. Okay, so negative 2 and 1 right here. And then it goes, if you plug it in, and then same thing as here too, right? So when you plug it in, it's maybe 0 is a 13. So I think it's too far. So let's put the now you can use a negative 1 here. So if you use a negative 1, you got 3 times negative 1 squared, but 12 times negative 1 plus 13. So 3 minus 12 plus 13, which is a 4, okay? All right, so negative 1 is 1, 2, 3, 4. This is 4, 2. Yeah, very narrow graph, you'll see. Okay, that's all. Our general method for the graphing the parabola will be as follows. So you need to determine the vertex and directions from the A and the axis of symmetry, x equal to h, vertex is h and k, and then the determine 2 points using the symmetry y and a series of often just okay. All right, so that's what I do. All right, next page. Now we are graphing a functions of 2 times x minus 1 squared minus 3. All right, so a is a 2, which is positive going upward. The vertex is already done for us. It's a 1 and negative 3. Okay, so 1 and negative 3 right here. And then you can just use f of x. No, you plug it in 2 times x minus 1 squared minus 3. Since the vertex is 1, so you can go to 2. Plug it in. So 2 minus 1 is 1 square. 1 times 2. The 2 minus 3 is a negative 1. So right here. Which means this is also the negative 1 too. And then you're done. You're graphing it. You're making a narrow parabola. Yep. Now, graph of the f of x equal to negative 2x squared plus 12x minus 9. Okay, so a is negative 2, which is going down. Okay, and then the h is, okay, you can use a component square too, but you can use a vertex format. Okay, so negative b over 2a. So negative 12 over 2 times negative 2, which is 3. Right? 12 over 4, 3, right? And then k, you plug it in. Plug in f of 3. So negative 3, 2, 3 squared plus 12 times 3 minus 9. So 9 times negative 18 plus 36 minus 9. Negative 20, this is actually the 18, right? So it's going to be a 9, isn't it? So if you write down as a vertex form, so negative 2 of x minus h squared plus 9. So vertex is 3 and 9. So which is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. And then now you plug it in because of 3. And then I can use a 4. So 4 minus 3 is a 1 square 1 minus negative 2, 7. So it'll be the 4 is going to be a 7. So 1, 2, 3, 4, 5, 6, 7 right here. Which means this is 7 too. So your graph is going to be parabola going down. Yes, that's it. Application. Since the graph of every quadratic function is a parabola, so that shape of the graph we call the parabola. Opening upward and downward, the vertex will always be either the lowest or highest point of the parabola. So this is the lowest place. And this is the highest place of the graph, okay? Which is this we call the minimum value. And then this becomes the maximum value. So when a is positive 1, you got the minimum value as a vertex. And then a is the negative. And then you got the vertex k will be the maximum value. Okay, so for this region, application problem regarding the quadratic function will be typically asked question regarding the maximum or minimum. Okay, so let's look at the questions. So when a car, manufacturers determine the fuel efficiency of the new cars. The highway miles per gallon is usually determined which the car is driving at 55 miles per hour. Why would this be the mileage used when almost every highway has an average speed that are significantly greater than the 55 miles? Okay, I actually, the missing sentence here, so I want to add it in. So this must be there, okay? So assume the function, we have to have a given function. I don't think that we can create the function with this kind of information. So the function will be m of s equal to negative 0.1 s squared plus 10.8 s minus 261.6 approximates the gas mileage M of S of a new car based on the highway speed S that a car is traveling, where the 45 between 85. Okay, so we try to find the maximum gas mileage and yeah, so we need to find the maximum gas mileage and the speed at which car reaches its maximum gas mileage. Okay, so what we can do is, since the A is negative 0.1, which is less than 0, so we are getting a downward parabola. Okay, so vertex that placed over here is going to be the maximum. Okay, so let's see what speed make the maximum gas mileage. Okay, now H is negative B over 2A. So negative is 10.8. 2 times negative 0.1, which becomes negative 10.8 over negative 0.2, which equal to 54. Okay, so H equal to 54. And then in order to find the K, which is a 50 miles per hour, right? So this is a miles per hour. This is S, which is a speed. Now the K is going to be the gas mileage, right? So F of H, which is F of 54, and plug it in. So negative 0.1 of 54 squared plus 10.8 times 54 and minus 261.6 become negative 291.6 plus 583.2 minus 261.6 becomes a 30. So vertex is a 54, and 30. So which means that the maximum gas mileage will be 30 miles per hour, mile per gallon, and this occurs when the car is traveling 54 miles. So if you drive 54 miles an hour or miles per hour, and then you'll use the 30 gallon per mile, that's a lot, isn't it? So if you're going to speed more than 54, which means 55, and then higher, and then the gas mileage is going to be the more efficient than the 54. So that's why every highway said that they need to do the greater than 55 miles per hour. So this is the gas efficiency. Okay. All right. Thank you for listening.